welcome back to the Creating Synergy podcast. Today, we're joined by Justin Coombs, a trailblazer in the biotech space and a true innovator who has spent his career turning bold ideas into real-world solutions. From researching antibiotics in wheat to founding the Carina Biotech to now leading groundbreaking work at AusHealth, Justin has continuously pushed the boundaries of what is possible, and he's playing a pivotal role in shaping the future of healthcare and innovation in South Australia. Welcome to the show, mate.
Thanks for having me, Daniel.
Really excited about this conversation. The biotech world is cutting edge in the way it's going. I guess I'll start off with the question, why does the work that you do matter? And why should the average person who's listening in care about biotech and the breakthroughs that are happening in that space?
Well, the reality is biotech's been part of everyone's life for a long time already.
Yeah.
What we're seeing now is more the complexity of things we can do with biotech improving. So if you like wine, you're a user of biotech, whether you like it or not. It's just a very ancient one. So some of the very earliest fermentations is sort of what you would think of as old school biotech.
Yeah, okay, great.
That's obviously over the decades progressed through to things like the discovery and production of antibiotics by Florey in the 40s.
Yep.
So that was a form of biotech where we learned to essentially use some of the technologies that were used for, wine and beer to ferment things like streptomyces to make antibiotics. That's, again, biotech helping us now. The world would be a very different place if we didn't have them.
Yeah, absolutely.
Right through to some of the really cutting edge stuff we're seeing now in healthcare, where we're looking at, genetically engineered immune cells to treat cancer. And, these could be replacements for things that are much cruder, like chemotherapy and radiotherapy into the future. And the reality is some of these first things are happening right now. If you had a kid that had a chemotherapy refractory leukemia right now, they would ultimately get prescribed a new CAR T cell therapy, which literally 15 years ago didn't exist.
Wow. It's saving lives, really, some of this stuff, isn't it?
Absolutely. So a lot of medicine now is biotech driven. In fact, I would say the bulk of the big things that we're seeing now around therapeutic antibodies, antibiotics, cell therapies are all effectively biotech products. But it's not just in medicine, actually. So we're seeing a lot of biotech around environmental remediation, in industrial processes, rely on a lot of biotech. One might even argue things like wastewater treatment is a very basic form of biotechnology.
Why do you love what you do? Like, what is your purpose in this world?
So, ever since I've been a kid, I've just loved sort of complicated things. And if you look at the world around us, the most complicated thing we've got is living things. We know remarkably little about them, which is sort of what makes it fun. I was at a conference a few years ago, which was not a biotech conference at all. I was explaining to someone about sort of the tools we have in molecular biology. And I used the analogy. I said, well, imagine someone handed you a 747. And you had to try and work out how it worked or even make it work better. But the only things you could do were take bits off it randomly or add bits to it randomly and then build one and see how it flies, which really at a very crude level is where we're at with biotech. So there's so much unknown there that that's just fascinating to get to play with these things. And
that is exciting. So let's go back. What do we need to know about Justin in your earliest context? Like, where did you start your career? Where did it all start?
Yeah, so it started right here in Adelaide. So I'm Adelaide born and bred, but I joke, I think a lot of Adelaide people are like salmon. We were born in our little creek here in Adelaide.
Come back.
We go and swim out in the ocean for a while and then we come back to spawn. So I am the quintessential cliche on that front. Started here in Adelaide, did my PhD here, went and worked in the US as a scientist for a couple of years, came back to Australia to do my legal training, but into Melbourne, and then finally came back to Adelaide to spawn. So and since then, had 3 kids, so generated 3 more Adelaideans.
There you go. They'll do the same.
Probably.
The process continues.
Absolutely.
So starting your career in antibiotics in wheat, tell us about that and where it all sort of took off from that point.
Yeah, it gets to this idea of the fascination with biotech, but also trying to do something. I was never really interested in sort of knowledge for its own sake. I was always interested in trying to think of a real world application. And it started with a silly idea between my supervisor and I at the time. So I did a honours project at Flinders Uni with Chris Franco, who was a fantastic and now retired academic.
Good last name.
Absolutely. So we were looking at antibiotic-producing bacteria isolated from soil. And there was this one class of bacteria in that family that was known to infect plants. And we thought, oh, well, what if there's more than just that one? So what it led to was a PhD project was conceived where we wanted to look at some economically valuable plants. And just to, first of all, screen them to see, do this particular class of actinomycetes live in economically valuable plants? And if they do, what are they doing there? So that led to coming up with a project, applying for a few different PhD scholarships. I was very, very lucky to be offered several, which so that really determined which plants we were looking at. So whether we were looking at horticultural crops, cereal crops or sugar. As it turns out, the grains people paid the best. So that was the scholarship.
Go where the money is,
no one goes where the money is in science. So
well, that's true,
the best of a bad lot, really.
Yeah, well, that's true.
So what it led to, though, was starting to look at cereal crops in Australia and, first of all, simply developing the methodological tools to see, can we look for these things in the plants at all? So that was the first year and so of my PhD, was just simply trying to work out, well, can we find them at all? Thankfully, we were able to find some of these organisms, and they were fascinating things. So they're essentially antibiotic-producing bacteria that make a whole bunch of medicinal antibiotics, but we found sort of close relatives that lived in the plants, and instead of making antibiotics that kill soil-based bacteria, what we found was they actually were very, very active against root pathogens. So it appeared that there was some sort of symbiosis that had evolved between the microorganism and the wheat plant to host these bacteria that are going to protect the wheat roots from disease.
Yeah, wow.
So what was really cool is we could then isolate them, we could grow them in the lab, and then we could actually inoculate wheat back with them.
Brilliant.
So, and what we showed is that we could actually protect the plants from fungal root disease by simply inoculating them with spores of the beneficial bacteria. Brilliant.
Which then grows the industry and has a major... So how has that had an effect on the wheat industry?
Yeah, so it's been commercialised and picked up by a couple of companies over time. But the biggest impact certainly was, for me anyway, was getting that sort of taste of, we can now do things that are practical. What it also shows is the journey from a good idea to something out on the market is very long, very drawn out, and really requires a vast amount of effort beyond that initial sort of interesting idea. But we are seeing a lot of this work going forward, and what's been really fascinating is that initial paper that was around how you isolate these organisms from wheat has now been cited many, many hundreds of times. So it's being used all around the world to look at isolation of endophytes, which are these bacteria that live in the plants, from a whole range of different economic.
How does that make you feel as the researcher on that knowing that people around the world are benefiting from this?
Yeah, look, it's great fun. It's this idea that, you've created something useful and put it out in the world, and it's it's a really nice feeling to have. But the reality is these early ideas, like I said, are simply the seeds of things that need to go forward, and we need to have lots and lots and lots of them, because that attrition rate between these good bits of interesting research and things that ultimately make it out to the market is very, very high. And we need, we talk about change. I think it's one of the big change things that needs to happen culturally, is that the idea of that attrition rate is real, and we need to accept it, and we need to almost embrace it, to say, we've got to push as many of these things we can, and if they don't work, so what? We'll go back and pick up the next one.
Yeah. So commercialisation is the toughest piece in all this, isn't it?
Well, it's probably even a step before commercialisation, and we might get to it, but I've got this sort of theory that we almost need what I think of as a third profession in Australia. There's the industry people and the academic people, and we've had all these efforts over the years to try and get academics to move into industry or industry people to move into academia and learn the language. My theory is what we actually need is almost a third group. That's sort of what I've tried to do with my own career, that sits in the middle, that are actually the translators, that, they intentionally don't become one or the other, and act as those intermediaries to get
it over the line,
out of the boffin's hands and into the industry hands. But there's usually quite a bit of massaging and work that needs to happen between those two extremes.
And is that when you say that's what you've tried to do for yourself? Is that where the idea of the Carina research came from? That you built, because you transitioned from, I guess, a researcher to an entrepreneur almost, didn't you?
Yeah, and look, I've always played on that interface. People ask me what I do for a job, and I say I'm not quite sure.
Yeah,
to be completely honest.
Still figuring it out.
Yeah, no, exactly, still figuring it out. When I was at school, I knew I was interested in biotech broadly, but I didn't say I want to be a highly cited researcher, or I didn't say I'm going to be CEO and make $1 squillion of a big company. It was just this idea of I liked making stuff happen. So I've really tried to always play at that space where it's the nothing to something phase, I call it. So, and Carina was the classic example of that. So that was just simply going, there's a real opportunity here to take this amazing technology that had been developed in the States for the treatment of leukemia using these genetically engineered T cells, and say, well, how do we take that opportunity and move it into other cancers? And what's been really amazing, I still find this stat ridiculous, is Carina is actually the first example of an Australian-developed cell therapy, or CAR T therapy, that's actually made it to the clinic.
So what does that mean for the people like me who are a bit more simple in their thinking?
Yeah. So I'll go back a step. Yeah. Sorry, I'll nerd out just for a minute. So CAR T therapies are an amazing thing. So we're all very familiar with the sorts of treatments that you would get for a cancer patient. We're familiar with surgery and radiotherapy and chemotherapy. And these are all, relatively speaking, quite crude technologies. So they're about simply cutting out a bit of diseased tissue or bombing it with radiation, which just effectively burns it.
Chemicals,
CAR T therapy is a completely different approach. So
is that like immunotherapy? Is it the same thing?
Yeah, it's actually the most cutting edge immune therapy there is now.
Yeah, wow.
So there are immune therapies now that are on the market. So you would hear about things like Keytruda and drugs like that. Yeah. And what those do is they broadly take the brakes off your immune system. So if you look at your immune system, how it basically works is it is constantly patrolling your body, looking for things. And it's regulated by largely by two signals. One is kill me and one is leave me alone.
Yeah. Yep.
So all the cells that are yours and friendly and good have a lot of leave me alone signal and not a lot of kill me signal.
Yep.
And cancers, you want to have lots of kill me signal and not much leave me alone.
Okay.
And your body is throwing up cancerous cells every day.
Yeah.
So, and your immune system is going around going, oh, don't like the look of you. Send in one of the killers, which is a T lymphocyte, to deal with you and move on. One of the things cancers evolve to, though, is learning to say, leave me alone. And what the drugs like Keytruda do is basically block the leave me alone signal.
Okay.
So what it causes is your immune system to become more hyperactive. Now, the good side of that, of course, is it can make a cancer that was once invisible to the immune system visible, and then you see some of these amazing reactions where, our next door neighbour is a classic example where she's had an amazing response to one of these PD-1 inhibitors, which, has been fantastic.
Well, I think, can I jump in there for a sec? My father-in-law had this, he got diagnosed stage 4 melanoma.
Yep.
And without sort of being disrespectful, like we were organising the funeral, like that's how far gone we thought he was. And he was in a bad way in hospital and all the above, but then went through this immunotherapy. And I, to be honest, hadn't ever really heard of this, even because this happened before I met you, obviously, and I hadn't heard of it. I heard of immunotherapy, but I hadn't heard of all these new things. And then we were learning about it. And I'm like, okay, and we all, as a family, made the decision. Yep, give it a try. It's like they'll put him in a test thing, a test trial, and it's been 12 months later, and there's no more signs of cancer. And we're just like, what do you mean? has he got cancer? Is he doesn't? Like, what is, and they're like, there's no signs. Like, it hasn't grown, it hasn't spread. It's got, like, it's practically gone. And we're like, how is that possible? Stage 4 melanoma, you're supposed to be like, goodbye.
So the most powerful weapon we have in the fight against cancer is the human immune system. It's the fighting fire with fire in all the same ways that cancer is good at evolving and dodging things. The immune system is adaptive. It learns to look for new things. So 20 to 30% of patients in certain cancers that get put on immune therapies have those sorts of responses.
That's amazing.
And what's fantastic about it is because your entire body is perfused with your immune system, then it can root cancer out of places that would be inaccessible to surgery or would be inaccessible to radiotherapy.
So is it surely that, because he's a pretty powerful mind as well when it comes to like, this thing's not bloody beating me. Is that an element of that in there involved as well? That you know the power of positive mindset?
Yeah, look, once upon a time I would have said, don't be ridiculous. When I was younger, everything was black and white. Everything was, very mechanistic. As I get older, I do start to wonder, are there holistic things that you can do? That we know there are a whole bunch of things that boost immune responses now, and some of them are, you wouldn't really expect. Sunlight's the classic example. So things that, whether the positive thought itself is helping, or it causes you to then go and do things that are otherwise helpful and otherwise generally helpful to your immune system, who knows? The reality is, who cares?
It's a part of the ecosystem.
If it works, do it.
Yeah, absolutely. All right, sorry, keep going.
Sorry. So, I'm doing a long and winding road up to
well, I cut you off. So
these PD-1 inhibitors, they're called, that just take the brakes off the immune system, were these first immune therapies, and they've just had amazing success. They're on market and they're working really well. So then sort of 15, 20 years ago, there was this idea, well, what if we can selectively take the brakes off the immune system? So rather than simply saying, well, we're going to take the brakes off generally, can we train immune cells just to react to something really specific? And if we can find a marker on the cancer, can we effectively have a homing missile at it? And that was what brought about the leukemia CAR T therapies. So these sound like science fiction, but essentially what they do is they involve taking some of your own blood, isolating out these serial killer cells that we know what they are. They're called CD8 killer T lymphocytes, genetically modifying them with a new receptor that doesn't exist in nature that has two really important functions. One, there's a bit that hangs on the outside of the cell, which effectively acts like a lock that will find the cancer cell and lock onto it. And then a bit that sits inside the cell that says, well, once you've locked onto that cell, kill the thing you've locked onto, and importantly, make more of yourself. So what happens is the T cell will go around, find its target. It'll go, all right, you're dead, and we're now going to make more of us that look the same to find more of these sort of cells. And that got effectively proof of concept against what are called lymphoblastic leukemias, and the results were just stunning. So the best story is a little girl called Emily Whitehead, who was in a US hospital at the time. I think she was about 6, had failed 2 lines of chemotherapy, was going effectively into palliative care by dumb luck. She was in the Children's Hospital of Philadelphia, where Carl June was developing these CAR T therapies. She was offered to be the 3rd ever human, 1st ever kid to be given these. Parents said, yes, what else? What are we going to do? Gave her a CAR Ts. For a week or so, nothing happened. By second week in, started to develop some pretty severe fevers and rashes and very, very strong immune responses. They got so strong, because this was in the early days, that it put her into ICU. Oh, shit. This wasn't the cancer. This was the therapy obliterating the cancer, as it turns out. Got to day 30, had her scan. She went from palliative care to cancer-free in 30 days.
In 30 days?
30 days.
Shit, talk about pointing the missile at it.
That's and Emily, you can look her up on the internet now, has gone more than a decade out and has remained cancer-free, which is just ridiculous.
That is amazing.
That
gives me goosebumps.
Yeah. That was sort of what inspired Karina. And so the idea was, well, what if we can take that technology that exists and adapt it, so instead of just reacting to these leukemias, we can have it react to other sorts of cancers. So then that set me on the journey of trying to find those markers on cancers that might present good targets. And then working with predominantly at the beginning, Simon Barry at the Women's and Kids Hospital. Never built a CAR T cell before. I was a random intellectual property lawyer going, I think we can do this though.
Yeah.
So over the 10-year journey, we've now got to the point where we have a CAR T cell in human clinical trials, first ever Australian developed one. And I can't speak for the human results. There's some encouraging signs, but certainly in mice, we can completely obliterate colorectal cancers. And not only obliterate the cancer, actually induce what's called immune memory. So you destroy the initial cancer, you leave the cells in there, and then you try and reintroduce the cancer and you can't.
Yeah, okay, wow. So if touch wood, but if anything ever happens to me, I'm calling you and just saying, is that how it works? Like, I'm just going, mate.
There's much smarter people than me to talk to, but yeah.
Throw whatever you can at me and get this thing out of me. I think the Emily scenario, did you ever meet her?
I met her dad.
Yeah.
So I've never met Emily, though we did have also an Adelaide girl actually participated in one of the very early trials, Lauren Krelsham, met her. After a CAR T therapy, and you're just going, you are wandering around because of Biotech. It's a simple
That's
thing.
amazing. How many lives has this saved? Do you know?
Oh, look, I wouldn't know the numbers off the top of my head. Though one of our collaborators in the US when we were starting Carino, a guy called Professor Mike Jensen, he was several hundred kids that he'd treated just in his lab.
That is so amazing. You must sleep well. There's not many people that can walk around saying we've had a positive impact on people's lives. In fact, there's hundreds, if not thousands of people in this world right now here still because of the research we've done.
Absolutely, but it's, we get to do the fun sort of complicated techie stuff, but, and at AusHealth is the classic example. We have our ventures team that's working on, really complicated, new therapies, new bits of health IT and that sort of thing. But even our divisions that do much more, commercial market-facing stuff, in some ways I'm very impressed in terms of the improvement in healthcare that they provide. So, we do a lot of work in hospital financial services that makes hospitals run better.
Yeah.
If we save someone's life because we've got the best healthcare or we've got more people through a hospital system, how is that any less valuable than coming up with a, very complicated biotech therapy that's
It is true.
Yeah.
I think that's located to that's based on a location. I think the research of what your studies and whatnot and commercialization of your product can do is have an impact globally, really, isn't it?
Absolutely.
Yeah.
The scalability factor is
huge. But I'm not taking away anything that it is just, for me, it's about the most, fundamentally, what I believe is good is for people to be able to flourish, right? And stay alive and flourish. And everything that you are doing, and the research in which you are doing is helping that.
Yeah, and that's the intent. I mean, otherwise, what's the point of it all?
So, what happens from here? Because you mentioned that you were an IP lawyer there at one point. So you went from research to lawyer back to research. Tell us what happens in this space in your life.
Yeah, there is a bit of a story there, but I'm not sure if it was intended or it's just evolved that way. But it gets to this idea that I mentioned earlier about almost needing that third group of people, I think, in our research translation ecosystem. So even as a patent attorney, I had a quite unusual practice in that I worked primarily with local innovators. So I was helping them actually get their ideas into some sort of tangible order, and we could file the patent applications and actually try and take these intangible concepts and ideas and turn it into some sort of property that could then have an enterprise built around it.
So you went from research back, and then you went back to uni and did a legal degree?
Yeah.
So and then it said, and on the back of you going, actually, there is this third space that I want to try to combat.
Yeah, look, and it was probably more subconscious than that. People have asked me before, how did you end up as a patent attorney? Yeah. And I joke it's because I don't like the city of Milwaukee, which has a story behind it. But essentially, I was postdocing as a scientist in the US, and I was starting to think of options that might bring me back to Australia.
Yep.
And I ended up just on a whim calling the IP law firm that we had filed the patent applications around my PhD work and said, oh, look, interested in coming back to Australia one day. What opportunities are there in the IP law space? As it turns out, within a week, I had an interview in sort of an early 2000s video conference setup.
Yeah,
a lot less
Zoom-like.
a lot less sophisticated.
Bit
than
more
what
pixelated.
We have now. That brought me back to Australia. But again, I kept on that theme of rather than just acting for foreign companies trying to get patents in Australia, right from the beginning, I was intimately involved with innovators and researchers. And in some ways, I think that was one of the best trainings I had in terms of translation of tech, because, there was really no other environment where you got to see such a breadth of work. So, I worked with many of the big universities in Australia, the biotech companies, and all sort of seeing their best and brightest that was getting over the filter of engaging the patent attorneys. So I got to see this amazing cross-section of work.
Yeah.
And from that...
What's some of the most exciting stuff that you've seen?
Well, look, a lot of the stuff in terms of the legal side of things I can't talk about.
Yeah, okay. Yeah, fair. Boring.
But I mean, a lot of the work we're doing now at AusHealth is fantastic. So we've got some of the cancer therapeutic work that's going on, but we've got some amazing work happening in sepsis therapy, which could see what I think could be a blood protein that's currently being thrown away.
So explain to me sepsis.
Oh, okay. So
therapy.
Sepsis is a disease you're probably familiar with.
Yep.
So, and this is what...
But we want to explain.
Yeah, what kills a lot of people. So basically, if you get an infection that goes from being a local infection from a cut or a wound, gets into your bloodstream, you become septic, which basically means you've got an uncontrolled infection floating around you systemically.
Yep.
And this kills a lot of people. Often it's sort of the proximate cause of death that might have other things before it, but that's what actually gets you in the end. And there's been some amazing work done at the Royal Adelaide here, where a couple of the doctors there, and I'll name check them just because they deserve it, so David Talpy and Emily Meyer, were looking at the blood profiles of people in septic shock. And what they actually found is there's a particular blood protein called CBG, and they found that if you had low levels of CBG in your blood, your chances of dying in a septic shock event were effectively tripled compared to normal people. And that went through to an amazing thought that, well, if that's low, could we intervene and actually bump up the levels of CBG in people?
Is that like iron shots and stuff like that? Is that kind of what you're talking about? Just give them a supplement and does it work? Is it that simple?
It's not quite that simple. But
I know you're laughing because I'm a dumb bastard over here, but
funnily enough, in principle, you're sort of on the mark.
Yeah.
So what we'd be hoping is that we can find ways of supplementing the level of CBG in people, and this could be quite acute though. So when you've gone into ICU and we think, your CBG looks a bit low, you're at high risk. If we could have stocks of CBG on hand where we could say, okay, we're going to supplement you up and we're going to then hopefully protect you from that massive mortality risk in sepsis. So we're doing some amazing work at the moment, which a lot of it's unpublished, but what we're showing is this looks potentially viable, and we've even found a potential source of the CBG protein, which if we can stock it in hospitals, then you could actually reduce the chances of...
How many people die from this per year?
Oh, septic shock's a massive thing. Again, it tends to be a consequence of something else. If you've got like a wound, or even after cancer therapy, if something's gone wrong and you've got an infection and it then goes rogue effectively.
So it affects you in so many different ways. It's not like you just got a cut in your leg and
No. So most wounds are fine. You treat them and they're all good, but typically, immune suppressed people, older people, cancer patients, a whole range of different settings where sepsis is the thing that sort of finishes you off. So
scary.
Catch it at the end.
I reckon a friend of mine just went through this, same age as me. Recently, I had an operation for stones.
Yep.
And got a really bad infection. Went back in. Yeah, it was one of my best friends, and he was in a bad way. And I think I'm remembering now that as you're talking here, I think it was sepsis related.
And it's really worrisome. Once you're getting to the point of having a septic shock event, then they're probably worried about you.
Yeah.
So
interesting.
The mortality risk is high.
Yeah, it was touch and go. So I want to talk about something that you mentioned to me previously, which I think is really interesting. Carina Research, which you are still, or Carina Biotech, you're still part of that. a shareholder, aren't you?
Yeah.
However, I mean, you founded this, you were a CEO, you scaled it from 0 to 10, and you've identified yourself as the, and you said it earlier, the 0 to something. And I think it's really liberating hearing you say that, and you've said this to me previously, that I'm not the guy that takes the business from 10 to 20 to 100 million and grows and scales it, but I'm the guy that helps it, starts it, understands it, builds a business, and then takes it. For me, it's really interesting to know that you've got the awareness of that, and I think I've had a guy by the name of Mark Randolph on the show. He's the founder of Netflix. He was sitting in that chair that you're sitting in, and he was the 0 to 10 million as well with Netflix, and he stepped away. And you look at that, and you think about how much he's possibly missed out on, but he goes, I don't regret it at all because I know my niche. I know where I'm strong. And then you said the same thing to me. I'm like, wow, it's enlightening. First, two questions I've got is, first, what is your approach to starting something from scratch? And then second is, then how do you identify the transition point in which you say, okay, now I'm no longer the person to take this to the next level?
Yeah, so look, I'll deal with both of those questions in order. So the starting something from scratch is working out sort of what components you need for that genesis event, I like to think about it. So there's an amazing amount of research out there, but a lot of it is not sort of suitable actually and when I say not suitable, I don't mean of a sufficient quality, but there are certain bits of research that lend themselves to commercialization and a lot that doesn't.
Yeah.
So part of it's trying to recognise the sorts of technologies that would benefit from a commercialization path rather than a public funding path or whatever it is that you might be able to do with it. And then the next bit's it's not quite a checklist, but there's sort of a rough mental list of things that you need. You need some very, very good people, both in terms of their skills, but also the temperament. Someone once said, startups are a contact sport.
Yeah.
So you don't do it lightly.
They're pretty rough.
Yeah, you don't do it because, you want an easy path going forward, but you do need people who, want to create something and get it out there and have, that resilience for when stuff goes wrong. And you'll see I use the word when, not if. It is a matter of when.
Yeah.
And then it's about, does the asset itself stack up? Is there a market that's going to be served by the product you're creating? Do you have a product at all? Is there something we can build an enterprise around here? Or, have we gone and published it? Have we made it effectively part of the commons already? And if you can knock off a few of those things, you'll find that the opportunities start to emerge as to which ones are going to be suitable. But even then, for everyone that you think might make it, there might be some that you'll invest a bit in and a bunch of them will die, and it's this pretty harsh funnel.
Yeah, it's continuous improvement, isn't it, and innovation.
Absolutely, and you have to have a willingness to lose right at the beginning because, 1 in 1,000 might make it through to the final product, but the problem is you can't tell which of the 1,000 is going to be that one at the beginning.
And I think what you're saying when you're talking about product, you're talking in particular from a biotech point of view, but I think about product in any, like from a widget to a service. I think it's all the same. It's in the sense that you have to trial and error, and you have to find out what actually is going to have the biggest impact on the community.
Yeah. And this is where sort of biotech's probably got a harsher funnel than most because, with widgets, we understand engineering a hell of a lot better than we understand
the human body.
Yeah, the way biological systems work. But then the flip side is exactly what you pointed out earlier. The impact you can have with some of these things is amazing. So it's sort of high stakes, high risk.
I was having this conversation last night actually with one of our clients, and I said to him, I look back when I started this business in 2018 and how green I was and what I know now 6 years later to what I knew then. And I think to myself, from what I know now, I never would have done. I never would have. It's so tough. Like, it is so hard. Yeah. And I think there's got to be a bit of naivety when you start in especially early days when you're just trying to figure it out and you've got because I think if it wasn't for that naivety, I probably wouldn't still be here today in the sense of like forging forward. It's like, oh, well, this internal optimist, I suppose.
Oh, and you have to. I mean, if you knew all the risks of something, particularly in my space, there's no way on earth you'd start it.
No.
So it's funny, actually. I speak to a lot of students that say, oh, I want to go and become a patent attorney. And I said, don't try to become one, because if you saw the path in front of you, you'd never do it.
Yeah.
So I think a little bit of naive enthusiasm is actually a very good thing.
Yeah, absolutely.
For some of these things. And it's what it creates are the sort of the spillover benefits. So, one person's failure of something is actually the next person's discovery of something. Yeah. So I think, you need it.
It's just the way it works. Yeah. So then the transition with Carina Biotech, you've said, righto, that's it. That's enough. I'm gonna step down as CEO. Yeah. And I'm going to hand this over. I'm going to hand my baby over to someone else to grow and scale. That insight, I mean, what advice do you have for navigating through that moment?
Well, a lot of it's about in my mind, it wasn't about seeing as any sort of failure. The way I looked at it, I went, this has actually got real legs. We've done the preclinical work. We've established an IP position that's looking pretty good. What this now needs is a bunch of different things. It needs vast amounts of money raised for it. It requires different networks to the sorts of people that, I had in academic circles and angel investors and grants. Yeah. And it requires almost a different temperament to go out there and pitch and raise money. And I remember thinking to myself, well, I could do it, but do I want to do it? And once you think, well, I've got two options here. I can find someone who wants to do it, and then I can continue to do things that I want to do, or I can sort of try and squeeze myself into this box that's not quite me. And then I thought, well, A, why am I doing it? And B, even if I did, is that actually in the best interests of the organisation and everything around me? Yeah. So I spoke to the chair. She was slightly horrified at the time. But I think, on reflection, best thing we ever did. Yeah. So Carina's gone on from strength to strength. We hired Deborah Athgen as seasoned clinical development biotech executive, whose areas of strengths were directly complementary to where I'd got the company. She's gone on to raise significant money and taken the product into the clinic. So on reflection, I'd encourage everyone to do the same. Yeah, well done. Stick to your passion, stick to the things that you love doing, and you sort of can't go too far, I don't think.
Yeah, it's difficult to hold the mirror up to yourself though in that space. I think with your notion of I don't want to be put myself in a box and do something that I don't want to do. I think that's quite clear cut. But when you're so connected to the purpose of what your business that you've created, your baby that you've created, when you're so connected to the purpose and vision and literally everything in your internal being is like, no, I want to see this through. Stepping away seems like kind of a contradiction, doesn't it?
Well, yes and no, actually. I think it's to the level you assess the purpose. At some point, you look at yourself and go, is the best thing I can do for my purpose to change the way I'm involved? And now it's not like I've stepped away from Carina in its entirety by any stretch of the imagination. I'll go to meetings and, Deborah will still introduce me as the founder, which is lovely. Yeah. I still have my options in the company. So it's absolutely still part of me. It's just, it got beyond my sort of day-to-day work. Yeah. So now I have my day job trying to find the next Carina, trying to see what we can do to get something going. And I think it's one of these things, I've talked about the numbers game before. We need lots of people having a swing at Carina-like companies. It shouldn't be an exception. Yeah. We need these over and over and over again, and we need to watch 90% of them die and let them, the ones that actually get through be the successes that will feed the next crop coming through, because it's a natural selection sort of game in biotech. So you just need big numbers.
I'm thinking of when you say you let them die, I'm thinking of, the Lion King, where there's like the bone, the graveyard. Yep. Is that kind of, is there amazing ideas and potentially life-saving ideas in that boneyard that just couldn't get commercialization because they didn't have someone like you? Or like, someone once said to me that the cure for cancer potentially could be in someone's inside of a kid's head or brain that couldn't afford an education, right? And like that's kind of always stuck with me in the sense that it takes a process to actually cure cancer, not just the idea itself.
Absolutely.
And the idea of this boneyard of failed biotech, why could you go around and search for some debris that you go, actually, I could revive this?
So I'd almost look at it the other way, actually. I don't think it's a boneyard of failed biotech, because in some ways that boneyard, come back to the salmon analogy, you hear about the salmon swimming upstream and dying, but they act as fertilizer for the soil, for the trees.
Yeah, okay. Yeah.
So those failed biotechs, actually, I don't mind at all. Those people come out with experience. There's data that gets generated. The only failure that I really see is where work is done not well and doesn't give you an answer. Yeah. Generating an answer that wasn't what you expected, I don't see as a failure at all.
Yeah, okay.
You still generated an answer you've added to the broader stock of knowledge.
Yeah.
Where I think we have a real bottleneck, particularly in Australia, not so much is the boneyard of failed biotechs, but it's the biotechs that were never born. So we see a lot of technologies languishing in universities, in research institutes, in health services, where there's great ideas, there's some drive, but it's quite hard to typically extract those technologies and get them out where they can have a chance at life. And that's one of the big reasons I came back to AusHealth was, we're uniquely positioned to actually give birth to some of these ideas and try them out. And given the nature of our structure, we've got I won't say a risk-free environment to work on them, but we've got the right structure to have a go at these things and see if they fly.
So tell us about them. What are some of the stuff? You've told me some of the amazing work that you guys are doing around, the Platypus Venom, which was one that just blew my mind, to the Bacteriophage project. Can you talk to us about some of the work that you guys are doing there?
Look, I'll talk to the Platypus Venom because everyone loves this story. It's a great Australian story. And I'll start with the thing everyone's worried about. No platypuses were harmed in the creation.
Do you know, I'm going to go out on a limb here. I did not know platypuses had venom.
No, well, and that was the finding that started all of this. And it's an amazing sort of biological story. So male platypuses have a spur on their hind leg that they use to fight with other male platypuses.
Okay.
And as it turns out, the venom in them is a molecule which effectively controls insulin production. So it's a hormone. So what happens is the male platypuses spike each other, and the winner, who spikes the loser, gives them a dose of this peptide. And what it does is it causes a massive release of insulin in the victim, as it were. What that does is takes all the glucose in their blood and packs it away, which they then have a hypoglycemic event and pass out.
There you go.
So what happens then, of course, is the male platypus that's the winner can go and entertain the lady platypuses and away you go.
And then
nature,
the cycle continues.
Yeah, and then the loser wakes up. But what's amazing is that
you'd be spewing.
The molecule that, for whatever reason, nature decided was going to be armed in the platypus venom actually is extremely similar to a molecule that we're all very familiar with, which is the active ingredient in Ozempic.
Yeah, Ozempic is
GLP-1 receptor agonist.
Yeah, for those who don't know, Ozempic, if you've been living under a rock, Ozempic is a really exciting weight loss drug, I guess, but it's been around for a long time because it's
started as a
diabetes drug.
So it's designed to effectively control blood glucose, but what people have worked out is some of the side effects of Ozempic are weight loss. So because it slows down gastric transit, there's a whole bunch of things. So
because when you say GLP-1 is the hormone. Is that the right way of saying it?
It's a peptide that acts on the GLP-1 receptor, which then causes the insulin.
Which tells you that you're full. When you eat a little bit, is that what it does? It tells you that you're not hungry here.
It's a key component actually in your sugar metabolism.
Yeah. Okay.
So GLP-1 comes up when you've got sugar in your blood. So then that causes the insulin to be released, which then packs the the sugar away. But then there's a whole bunch of physiological effects as well. So it slows down gastric emptying, which is sort of the fullness factor. So it's a molecule that's doing amazing things at the moment. It's a classic example of where the market's gone a little bit funny as well, in that there's now a whole bunch of diabetics that they're struggling to get supply of their GLP-1 RAs because the Hollywood celebrities are all trying to do it to get thin. So, but where we went with Platypus is, now we're probably going to change the name, but it's stuck with us for now.
Platypus.
Yeah.
Is that?
Where we went with the idea was, well, nature's designed this sort of long-lasting GLP-1 in platypuses to knock out the loser for quite a while, whereas human GLP-1 has a very natural short half-life because you want it to turn on and off quickly depending on how much glucose is in your blood. So we had this sort of crazy idea, and this is when I was at AusHealth the first time, actually. What if we could actually mix the molecules? So we could look at what the molecule the platypus uses, and we could look at the human version of GLP-1. We had them made, and over the last couple of years, we've tested them and they work. So we know they...
so tested them where? In humans or in mice? Or?
Yeah, so first of all, just in cells to see can we get insulin production induced, can we control blood glucose. We're now moving into animal models, so we know that these things can induce insulin production in mice.
Yep.
And now what we're about to embark on, in fact, we've just approved some new funding, is, you believe it or not, you can make mice fat by feeding them effectively the mouse equivalent of the McDonald's diet.
Yep.
We're fattening up some mice.
What's that, like cream cheese or something? What's that?
Well, they just call it the high-fat chow. It's very scientific, but basically it's Macca's for mice.
Yeah, there you go.
You just feed them that for months. They get horribly obese. And then we can give them
and
some
test
of the Platypus and see if we can actually get them to drop the weight.
So are you building this as a weight loss drug or as a diabetes?
Well, they're always intimately both.
Yeah, okay.
So what we are going to want to do, though, is start to think about, well, how do we differentiate this from some of the molecules that are on the market now? You've already pointed out, and it's a really important point, that the level of development around some of Ozempic and its sort of friends will drop off a bit because they're becoming old molecules. They'll become generic. So we're coming in with what we think are new and different. And then we also got some clever ideas around, we think our molecules might be a little bit more amenable to better ways of delivering it. So at the moment, Ozempic is largely injected.
Mm-hmm.
People don't like injecting themselves. So we've got some interesting ideas about how we might be able to adapt our molecule to other ways of being delivered.
Like ingested or something? Or
yeah, oral's one, but there's actually some even cleverer ways of doing it, which I won't go into now. But yeah, there's other ways that you can get Ozempic into people, we think.
Brilliant.
Which doesn't involve having to stick yourself with a needle.
Well, when you were in human trials, give me a call. I've got plenty of weight to try to remove. I'm more than happy to help out.
Everyone around the office is all trying to sign up.
Are they?
We're not quite there yet.
That's hilarious. So the other one that we were talking about recently was the phage project, the Bacteriophage project. Can you explain that? I thought that was really interesting.
Yeah, so this one's actually a rebirth of a very, very old technology. So in sort of the 1920s, people were developing these bacteriophage to treat bacterial infections. So
can you explain what bacteriophage is first before?
So I'll go back a step. So bacterial infections, we're all familiar with them. You get a nasty chest infection, you might have a Pseudomonas or something like that. So these are bacteria that get in and make you feel sick.
Yep.
So in the same way that the bacteria is making you sick, bacteria themselves also get sick.
Mm-hmm.
So they have diseases too.
Because they're a living thing.
They're a living thing. So it's, this whole fractal idea that, even the fleas have fleas. Sort of thing.
Yeah.
So bacteria themselves have pathogens that make bacteria sick, and they are bacteriophage. And what they are, they're an amazing virus particle, basically. And these things infect bacteria, give the bacteria nucleic acid signals to make more phage, and then they end up making so many phage in the bacteria that the bacteria itself explodes and releases all the phage.
So it's like the enemy of the enemy here, isn't it?
Enemy of the enemy is my friend. So that is the classic example. And what's really nice with a bacteriophage is they're beautifully adapted to killing bacteria, but not adapted to infecting humans at all. So you're full of bacteriophage right now. And they're all trying to keep the bacterial colonists of you in check. So what we've been doing for the last few years is working with a group out of the Queen Elizabeth Hospital to start trying to isolate bacteriophage that are particularly good at killing bacteria that we don't like. So these can be respiratory tract infections, so lung infections, upper respiratory tracts. There's even some amazing work coming out of UQ where there's some bacteria that are implicated in skin cancers. See if we can control them. Bacteria that infect wounds, all these sorts of things, and we can manufacture them pretty easily. And what over the last few years this group's been able to do is, again, manufacture some of these and actually start treating a couple of humans. So we've got an a clinical trial called the airspace trial running out at the QEH right now, and that's treated some patients.
Beautiful.
And we're also starting to see some potential to even treat patients under what we call compassionate use, where people could come to us and say, I've got this recurrent infection, antibiotics aren't working. Can you make me a phage tailored to my infection?
That's amazing.
Completely workable. And again, it's this idea of harnessing biology to help us, so much more sophisticated than trying to use chemical poisons or something like that.
How much does this get involved with the gut health and the gut bacteria and the microbiome and all that? How does this sort of, because the gut health thing is kind of exploded in the past 5 years or so. Everyone's becoming more and more aware about, people are saying it's almost your second brain and all these different things. Can you explain how all this comes together?
Oh, look, your gut microflora are almost certainly held in check by a population of bacteriophage. In fact, if you get a Clostridium infection, that's almost certainly involving a component of it getting out of whack with the other bacteria in the phage. So one of the things that we have started some research on is, can we get phage against things like Clostridium and some of those bugs? We're even playing with the idea of other gut pathogens where we might be able to try and isolate some phage against them. Wow. Again, it's this classic example. I think I made the point before. There are so many opportunities for development of new biotech products if we've just got the will and the resources to do it. But clearly a big thing. And you can see there's already some work going on in the space with companies like Biobank looking to essentially achieve the same end of rebalance your gut microflora. Now they're taking the approach of fecal transplants.
Yep.
But again, you could approach it via the phage side of things as well. If you can find a bacteria there that you want to try and get rid of or at least control, then, rather than having to have something like an FMT, what we'd be hoping for is you could just pop a capsule of phage and away you go.
The one thing that this is probably more on a personal thing, my wife had to go on a host of antibiotics for a while there, and I fundamentally believe it's sort of had a bit of an impact on her gut health, where she's got rosacea and stuff like that. And is that something where this type of work that you guys are doing can help, like replenish gut health and build the is that where it's going, or am I way off the track here?
No, theoretically, yes. So one of the things so antibiotics have been an amazing thing for medicine. So they've saved essentially innumerable lives going forward. But one of the problems with antibiotics, and it's being recognised now, that killing bacteria is a double-edged sword. Yeah. So you'll kill the bad guys. That's great. But a lot of the time you'll kill some of the good guys as well, and that's where you can get some of this dysbiosis in the gut, where you start to say, well, actually, we would have much preferred to have just killed the bad guys and left the good guys alone. And we actually think that's one of the primary opportunities with phage, because they actually have variable, what we call host range. So what we can do is then also select. So we can say, right, we want a phage that specifically kills the bad guys, but leaves the good guys alone. So, and we can simply screen for it. So you can say, well, which phage are doing that and not doing that, which again, because we can take a personalised medicine approach with a phage treatment, it's a lot easier to do than something like an antibiotic where, you've got to have a one-size-fits-all approach.
It's amazing. What outside of that, what's the most exciting thing in the biotech space that you're seeing right now?
Yeah, look, I think we're working in a lot of it.
Yeah.
Now I think the the sort of synthetic biology and immune therapies still have a long way to run. I think we've only just scratched the surface of what these things can do. And it's, I think we'll start to move into applications outside cancer. They've got huge application potential for things like autoimmune disease. And because what we're really recognising is the sort of central role the immune system plays in a whole range of disease conditions. It's, not just inflammation.
Yeah.
It's got a pivotal role in cancer, it's got a pivotal role in infection, it's got a pivotal role in autoimmune disease. So I think if we can start to pull apart that 747 and understand really how that immune system works and how we can tailor it to do certain things, then I think that's the bit that I think is really exciting, and it's coming off the basis of development of a whole bunch of basic research tools around, actually being able to genetically engineer an immune cell. Without that earlier work, you'd never be able to do some of this applied stuff.
As you're talking there, I'm thinking about the conspiracy theorists of the world, right? I know, not that I want to dive into that too much, but there's the common talk, especially on social media, where you see people saying, there's cure for cancer, but the governments aren't releasing it. There's cure for motor neuron disease, but they're not doing this, they're not doing that. What's your answer? What's your response to the conspiracy theorists of the world who think that these cures are already available, but just not being released by way of controlling population and everything else?
So there's probably a kernel of truth in it, but not the one they think. And I think it gets back to this point that you made earlier. The cures for cancer and various diseases are probably sitting in the head of some kid right now.
Yeah.
So I suspect there are amazing breakthroughs that are sitting out there that remain unrecognised or unexploited. I don't think there's an active campaign to suppress them.
Yeah.
But I do think a lack of opportunity for these things to get translated or at least tried is probably holding back some things that are there. I mean, every great therapy started as a stupid idea or something that was just lurking on someone's bench at some point.
Yeah.
So I think it's one of those things where there's a kernel of truth that's being looked at probably in slightly the wrong way, to be completely honest. But
so it's not the government suppressing it, it's just the lack of availability of funds and opportunity, or
it's not even funds necessarily. So we spend a lot on research in Australia. I think it's more the way we deploy it. We do a lot of very good basic research, but we do tend to leave pushing some of these things toward the market a little bit underfunded. And I think it's also a cultural thing in that in some ways we're quite happy to say, aren't we doing great research? Here's the papers. But taking that next risky step where you put yourself on that harsh funnel that I talked about is something that we don't naturally do in Australia.
And what's the point of the research if we're not? That's the point you're trying to make.
It's
the third space that you're trying to create.
Exactly. And I think we need that third space because typically it's the technology that's still too risky for industry to be able to go, we're ready to run on this. But it's got to the point where it needs more than what the academic researchers are willing to do. So it is, how do we identify and drag through those opportunities, and what do we need to do along that path to polish them up ready so they do become backable?
When you say it's too risky, what do you mean by that? Is it risk to human life? Is that what you're saying?
Oh, no. Typically, it's commercially or technically risky.
Okay.
So when I say too risky, I don't make now. Controlling things like actual medical risk is something we're really quite good at. We have, the whole clinical trial regime for a reason. And that, I think, is really quite polished. When I say too risky, it's more, people, are they willing to risk something, failing spectacularly?
Yeah.
And I think it's something the Americans do better than us.
Yeah.
So
they're just like, what the hey?
It's let's have a crack.
Well, they got the startup mentality over there.
Absolutely. And I think it's also a cultural thing. So, people look at someone with a couple of failed startups behind them, they go, okay, you've got some experience.
Yeah.
Rather than, you're now doomed for the rest
Whereas
of
in Australia, it's if you failed, you failed.
Yeah.
Yeah.
Which has a really chilling effect.
Yeah.
Because then people tend to go into derivative predictable areas because they think, because it's
it's a shame, isn't it? Yeah. Look, we're that the business that I run and operate is big in the change space. We work with a lot of organizations, helping them through change and transformation. I am really interested in your expertise in this world because I know that what you guys are doing at AusHealth, you're doing some really amazing change and transformation programs out there. But we often talk about the concept with SynergyIQ, we often talk about the concept of sense making and how to help people understand and navigate complexity during times of change. And in the biotech world, digital world, AI, everything that's happening, there's a lot of change. How do you help? When you set out to lead through change, how do you help your teams and your stakeholders make sense of change, especially in a world that's so complex in what you're doing?
I think a lot of it's about establishing the why, like why are we doing this at all? And if you can get sort of the hearts and minds as to the purpose of it all, then I think a lot of the steps, even if they're quite abrupt or big, start to make sense, and people go, yep, well, this might be uncomfortable, but I can appreciate why I'm being uncomfortable here.
Correct.
And I think I think some of the poor change that I've seen happen in other organisations has been where someone's gone, well, we're just doing this, and it's, why do we do it? Well, because.
Just go and do that, because exactly. That's what the exec said.
Yeah, whereas I think if you can establish the why and you can, try and build that case, pitch the reason, this is going to help us in the long run, or it's going to help someone else in the long run, it really smooths that path forward, and you can get people, willingly embracing it rather than resisting.
How do you put that in practice? Because it is a difficult thing, right? And what we typically see is that the executive team have been talking about change and transformation and the strategy and all that for the past 6, 12 months or however it might be.
Yep.
They're building this plan, new strategy comes out, bang, we're going to make all these changes.
Yep.
And then they don't understand why the people don't understand it, but in their head, they've been working on it for the past 6 months. It's just like you haven't allowed your teams to absorb it. You haven't communicated it correctly. Yep. How do you combat that?
So look, in the startup world, everything is effectively that situation. Yeah. So I go back to this idea of, before you're doing practical things, you introduce the concept and, try and get the vision bought into more than the what.
Yeah.
And if you can sell, the big picture of this is going to be good, then I think it smooths it through. And the classic example was starting Carina, getting them onto sort of, I won't say being an evangelist, but this idea of, there's a massive opportunity here. Are we wanting to go and chase it? We know all the things that could go wrong. We know this is high risk, but we've got an opportunity here. Do we want to take it? And in that case, we were able to do it, but it's about having that sort of, I hate the cliche, the light on the hill, but the idea that there is, a big picture that we're chasing.
And then when you get the stories of Emily, as you said earlier, that only fuels the need to want to do more and change more and innovate more.
So I used to start my funding pitches for Carina with the Emily story.
Yeah.
And because it's such an easy thing to relate to, and, people say, we don't care if this is high risk, we think this is worth a swing.
Yeah.
And I think if you can do that, it's great. Now, obviously not every, change you're going to implement is, chasing the cure for cancer.
No.
But again, if you can have that thing that people can just relate to, then I think it really helps.
Well, they need to make sense. Exactly. They need to make sense of why we're doing this. I think people are more likely to step into the ambiguity when they understand why they're doing it. We often like it to a goat track. Have you ever heard of the analogy of a goat track? So if you think about a house on top of a hill and you go, this is the path that we've always gone. This is the way we're asking you every single day to get to the top of the hill, take this path, walk this path. It's nice, it's gravel, it's tree lined, all the above. And then one day executive comes along and says, right, you're going down the goat track now.
Yep.
You're not going up that path, you're going to the left. And everyone's sitting there and going, well, hang on, it's muddy. Like, why would we go? Like, that's not... We've always done it this way. This is the path we've always gone. Why would we take the goat track? I can't make sense of it. So it's our jobs as leaders, as we embark on changes, to help people understand why we're taking the goat track, and then make them feel safe while walking on that goat track.
Exactly. And again, when I was at Carina, I think that was part of it, to say, we are embarking on something risky. We're getting you to do research that you haven't done before. But my job as the CEO of the organisation is to ensure the resources are here, and this isn't going to trash your reputations if we do something silly.
Absolutely.
So And again, it puts a bit of load on the leaders, but I think it's what they're there for.
Well, that's their role, isn't it?
Exactly.
Can you talk to us about the changes that you guys are going through at AusHealth? Because you're looking at AI in a special way, aren't you? It'd be interesting to unpack that.
Yeah. So what we're starting to really see is AI making inroads into the healthcare setting on a whole range of fronts. So we've got 2 live AI projects right now. And what it is, it's all about, or the way I like to think of it, it's about converting the mountains of data that we have in hospitals and healthcare and turning it into information that's useful to clinicians, nurses, whoever. So we've got, in fact, we've just had a little AI software company move into our building. So we've really embraced it.
Brilliant.
So we've got our accelerator space down at AusHealth, and our first tenant was a healthcare AI company.
Great.
So we've got a project that's actively looking at making sense of massive streams of data that come through intensive care units and turning it into doctor digestible information that they can start to make more informed clinical decisions. They can look at histories of patients through hospitals, how patients have come in and out of the ICU, longitudinal observations and that sort of thing. So we've got that to the point where there are working prototypes right now down in the Royal Adelaide, which is amazing.
Is there any risk with that the AI might be wrong? Is that something that people are worried about?
No, so what we're doing with the KISS project, as we call it, that's actually not creating anything new with the AI. It's actually about assembling the information or the data that's already there just in a more digestible way. So it's all about the human factors. Well, how do we make, exactly what you said, how do we make sense of this mountain of information's there in the best way for the human to interact with it? Yeah. So that's
exciting.
Going along beautifully. And actually,
is anyone else doing that, or is that something groundbreaking?
No, look, as far as we can tell, I think we're the only people building a similar tool. And what's been really nice, and this is again one of the strengths with AusHealth, is we actually try and work with the clinician end users right from day one. We don't do the build it and they will come theory. We actually go, okay, who needs to use this? How are we going to make it partner with them to them? And obviously our connection with SA Health and the Central Adelaide Local Health Network has been instrumental in getting some of these tools really tailored to the hospitals that will use it. But our other AI tool that I'm really proud of, because it's one we started just recently, is looking at making hospitals run more efficiently in terms of the way they interact with their billing and Medicare. So at the moment, there are teams of people, I didn't realise this was the case, that take doctors' notes and convert them into billable events for Medicare.
Yeah, wow.
And that's how hospitals fund themselves. So what we're looking at is building some tools that will help these clinical coders, as they're called, actually, again, take that mountain of data that exists around a patient's experience with the hospital and more easily turn it into these billable codes for Medicare that's, not onerous, more accurate, and actually meets all the many administrative and detail requirements that are needed to get these bills through.
That's exciting.
So again, trying to help the coders rather than, we're not looking to replace any humans with AI. We just want to make their jobs better and easier. So we can have, more hospital people doing hospitaling and less time doing admin things.
Yeah, productivity at its finest. So that's what it's there for. Going back to the first AI piece that you're looking at and grabbing the data on the individual, I was informed of I don't know if this is actually in play at the moment, but the idea that AI could, and coming back to Carina Biotech and cancer and everything else, that if with the amount of data that we have in the world, we could potentially understand genetic makeup. So you're an Anglo-Saxon 40-year-old white male or a 30-year-old female, African-American female, or whatever it might be. And you have a particular type of cancer, let's call it, I don't know, bowel cancer or what have you. And with all this data across the world, you could look at, in an instant, what a person with your similar blood type and genetic makeup and the therapies in which, and what's been the most successful. Yep. And then pull that data in together and go, right, there you go, there's your one. So it's no longer your your doctor that's making the call. This is what's had the most success rate, and we'll start with the number one on the list, and we'll work our way down if that doesn't work. Is that available? Is that something that's happening?
It's being built as we speak. So, but the bottleneck with all of that is what we call the functional genomic work. So yes, I know all of your genetic variability, and I know how you went in your therapy with the drugs that we used. But the hard bit is still sort of the wet biology bit of knowing that, well, the correlations effectively. So if you've got this genetic makeup and there's, 20 examples of people like you, and we tried 20 different drugs, and then we can start to say, well, this makeup tended to work better with this drug. But what we still need to do is the wet biology work of saying, well, who did well with what? So the markers are very easy to get. It's now doing what we call the functional genomic work. So you can say what are the drivers. But this is happening now. So there are biobanks of cancers that are being established. Cancers get profiled for various markers. In fact, we have an active project now at AusHealth where we're actually trying to match drugs to certain markers in childhood cancers. So that's sponsored with the Von Braun Foundation. So we've got projects working in that space, but that's a massive global task. And the bigger that database gets, the better, because eventually you'll get to the point where you can start to get some evidence-guided data on how a particular individual's cancer could be treated.
Yeah. And isn't that what we want? Like, we want that to actually happen. And the way it was put to me was, imagine if one of your children was suffering from this particular cancer and all the information is there readily, but you just not allowed to do it because of privacy laws or all this, the other.
Well, I mean, some of it actually, this is where the personalised medicine of things like CAR-Ts starts to make sense. So, as I mentioned earlier, the Carina CAR-T is directed against a very specific protein that lives on the cancer. And the way patients are selected to go onto the clinical trial is they're actually screened. So they take a biopsy of their cancer and they say, do you have this particular protein or not? Because if you don't, we're not going to put you on the trial. And that's, we're very much at the front end of this personalised medicine approach, but eventually with enough data behind it, you'll be able to say, okay, well, here's your list of markers. Here's all the people like you that have been treated with various different drugs. We think it'll be drugs A, B, and C that will be the best bet for you. Or even more cleverly, well, these markers are cancer associated. We're going to build a bespoke immune cell to attack that.
Yeah, that's brilliant. Well, when's eventually to you? Like, what is eventually?
Well, CAR-Ts are happening now.
Yeah, but when does this become? Is it mainstream now? Like, when does it become business as usual?
So I don't think there will be an event where one day we'll wake up and go, personalised medicine's a thing.
It's just
it has been creeping already for years. And it will continue to creep, and the granularity of those decisions will get smaller and smaller and smaller and smaller.
And so, from a number perspective, is it that we in the next 5 years should see a massive transformation in the way in which we view?
Well, again, I don't think there'll be a cliff. We're seeing it now. So there are already prognostic predictors of cancer that you will get screened for that are associated with, better or worse outcomes. We've just looked at one now at AusHealth where we've got a predictor of whether one of these PD-1 drugs might actually work for you or not. Because, being able to pick that sort of 20 to 30% that have the amazing response from the rest, we think patients would like to know which bucket they're in, before they start, which will help with some of those decisions. So I don't think there'll be that step change. I think, in 20 years' time, you'll look back and go, oh, God, things were a lot cruder back then. But I think it'll be a gradual.
So, question, and it's a tough question and one that I don't want to put on you on the spot with, but if a family member or a friend or a relative or someone came to you in this day and age and said, I've got cancer, stage 4 cancer or stage 3 cancer or whatever stage they are, what would your advice be to them right now?
Yeah, so it would be to obviously work with your oncologists. I mean, these are guys and girls at the cutting edge of what they're doing. I think there's an amazing raft of clinical trials that are happening at the moment. Right now, If a cancer was suitable for treatment with a PD-1 inhibitor, I think they're the ones that are pretty mainstream for a lot of cancers. Not every cancer is responsive to these PD-1 inhibitors, but they are. They have been an utter game changer in terms of cancer therapy at the moment.
So so you can say, I want a PD-1 receptor trial or something like that. Is that what?
Yeah, so there's a bunch of trials, but there's a bunch of commercial drugs now as well. So again, if your oncologists are, trained,
they're well aware of what's going on.
Well aware of what's going on, not just what's on market, but also what trials are available. But again, if one of my daughters got a leukemia, I'd be lining up for the CAR T therapy as well right now. And that's been an amazing thing that's literally happened in the last 5 years.
So
getting on market.
So you would say that we're in Australia, your cardiologist would have an absolute awareness of all the potential trials that are going on in the world?
No.
Yeah. And I think that's the point, is that there might be some stuff that you miss out on and you lose a family member, because that's kind of how do you know?
You can't expect every doctor to be aware of every trial that's around. One of the things, actually, we do have a very, very sort of driven, tech-focused ophthalmologist, actually, that we work with at the RA. And he's got a real interest, actually, in developing some tools that can start to flag potential trials for patients based on their demographics from his records, which I think is a cool idea, which gets to your point.
Correct, yeah.
Where you can say, you're not relying on that unrealistic expectation of a doctor knowing every trial that's going, but to have software that says, okay, well, you meet this, and this inclusion.
There's a database. Brilliant.
And the databases exist. So clinical trials databases exist for both Australia and the US. So the data's out there. So again, it's how can we use some of these AI tools to start making those connections between these big pools of data and turn it into useful information.
And are the trials that we have available here in Australia, are they Australian-made only trials, or do we have access to American?
No. So Australia's a very popular trial site for globally sourced innovative products.
Yeah,
so we have a lot of trials running in Australia that are products developed overseas.
Elsewhere, which is exciting. For this industry to continue to forge forward, it's going to need some real leadership. And this third space, I want to keep coming back to this, because it just sounds like to me that there is a lot of potentially a lot of missed opportunity in this third space of how do we actually get what is an amazing research and biotech research into a commercially sound product. Leadership is something that I'm very interested in. Who is leading this in this space? Who is and what does the world need from a leadership point of view in this space?
So I think it's an emerging need. I think it's starting to be recognised. I think we did spend a long time trying to push from both sides rather than grow something in the middle. So I think we are starting to see some appetite that actually, no, this is something that's required in the middle. I've used this line before. I said, the only way tech, as far as I'm concerned, gets out of the lab and into application industries if someone carries it. So I think it's a quite human-driven thing.
Yeah.
There've been attempts to systematize things with various IP and commercialization models, and try and turn them into a bunch of rules, and it's just going to happen. I don't think they've worked particularly well. What I think we need to focus on is the cohort of people that are going to make those connections, assess those opportunities, because at the moment we still can't, I think, make it down to a systematized set of rules. And I think the drive and desire to do it is something that still is an inherently human thing.
Yeah.
But what we are starting to see is recognition from both, I think, the research community and industry to say, well, there is this group that we want to try and build in the middle. And we're starting to see some real efforts, actually, from things like the Cooperative Research Centres program in Australia, where they're really starting to position CRCs as that bridge and people associated with the CRCs as the people that'll do that carrying across the divide between academia and industry.
Yeah, beautiful. If they're like, what do we need to know that right now? I think that's kind of the question. Like, there's a lot going on in your brain. And obviously, there's things you can't say from a legal standpoint and all the above. But to the common folk out there, whether it's about cancer research or whether it's about health care in general, or what is it that you think we should all know and think about?
Look, think what we should think about is that people are trying. We are actually out there trying to develop these things, and I think people should be supported to do it. And again, it's that cultural thing. If someone tries and fails with a bit of tech, it shouldn't be, oh, you failed. It's well done. Where's your next one? And that's one of the things that, again, we really want to do at AusHealth. We want to have that sort of recirculating group of people and tech saying, our job is to try and launch things, and some will fly, some won't, and we fully accept that from the beginning. And I think if we can get people starting to have that mindset of trial and error and pushing it forward. And I think one of the things that we also need to do is build opportunities for people to move into the space as well. So, we do a lot of science push, particularly with kids, but then you can see it, a wall is hit where they go, oh, actually, where does this go now? Yeah. So how do we build that industry around what we're doing to, give opportunities for, the next one of me coming along that goes, you know what, I really want to get into technology translation and not have to say, well, I'm going to have to just go and forge my own path. There starts to be archetypes and pathways for people in that space.
Yeah, I saw, with the defense industry, the way it's going and the engineering space and I even saw an ad on social media from SAPOL the other day that targeting year 12 students. And I don't know if you saw that as well. Targeting the year 12 students who have just successfully completed year 12. There's a lot of industry that is after the younger generation to come in. Yeah. This one here seems to me as if it's one of the most important, that you don't see the advertising and the. I don't. Is that something?
And look, there is always a bit of a push, but I'm a big believer in the pull. Actually, if we build, companies that are doing cool things, if we put the Karinas up in lights, you're going to get smart kids going, actually, I want to go over there. Yeah. I don't need to.
Because it's kind of sexy work, isn't it?
Pushed into it. So that's sort of my own philosophy. We need some of that cool sort of startup-y culture happening, and where you actually get the best and brightest wanting to do it.
People want to change the world. There is a cultural transformation here, though, isn't there, of the whole industry? It was kind of what you said earlier. How do we change the culture here within Australia around the startup space and the failure space? Like what is your perspective on it? As opposed to just going, look, just copy what America are doing. Like what can we do here in Australia to remove, especially in South Australia, remove the tall poppy syndrome, all this stuff that happens? How do we culturally change and shift this industry?
Yeah, look, if I had all the solutions, I'm putting them out there, but I think we can only just do it, actually, is the most important. I don't think people will be told how they should think. I think what we need to do is try and lead by example. And I'm hoping, fingers crossed that, companies like Karina do amazing things and it'll spawn the ones coming behind it. And we'll start to say, people become famous not because they're really good at football, but, they started company X and that was a cool thing. Yeah. And we'll start to build some of the ecosystem around it as well. So, you'll get the professional services that'll be, there to support that startup ecosystem. And Adelaide's sort of a cool place to do it because we're, I think, about the right size. What we don't have, obviously, is the huge pools of capital like they have in San Francisco and Boston. But I think we've got a nice size for getting things done. So I think we'll have to do it in a sort of Australian style. It won't be the big brash American way of doing it. But it's not to say there isn't capital here for good ideas, but I think it's more convincing people that spraying some money at a little biotech company is equally fun as, buying a waterfront apartment in Sydney.
Well, that's right. Yeah. Because it comes with a bit of risk, doesn't it?
Absolutely.
What excites you about the industry? Looking forward, if you're going to cast your mind forward 10 years, what's the most exciting thing about this biotech world?
Yeah, look, to me, it's about getting some of these new things out there. And and it's not focusing on any particular one. I want people to come to events and, talk about their cool little project they're working on and, the successes and failures they're having. And I want to see some people coming back for rounds 2 and 3 and 4 to say, that project wasn't good, so I'm working on the next one. And there's that support network around them to do it, which again is probably a bit of naive enthusiasm.
Yeah.
That's where I'd really like to see things going.
What's your proudest moment in all this that you in your journey so far?
Well, that's a tricky one. I know I've had some, just little vignettes almost. I remember one of them was a Carina moment where we saw the very first animal data actually at a social mixer, and one of the scientists said, Justin, I've got something to show you. Pulls out a folded piece of paper just with a graph on it.
Yeah.
Actually, that makes me think, there might be something here.
Yeah, wow.
So that was an amazing moment. And just when you have, again, for me, it's always those sort of genesis events where you see something appear for the first time. We've just done one at AusHealth where we've got a large US investor showing some interest in one of our techs, and you think, God, this really could launch this one.
Yeah.
So where you have those events where you think, right, something's going to happen here. I don't know what it is, but we're going to have something happen.
It's that excitement that brews.
What keeps you coming back.
Do you ever get frustrated that you can't get the money for something that you truly believe in? Or is it a case of actually this is working and the money sort of just comes?
The money never just comes. You've always got to, pitch it and try it. But I'm not sure it's necessarily a bad thing. You don't want money to be too easy because that can actually be a little bit counterproductive. So you do want discernment in your investments in terms of, who's putting money in. The problem is, one person's discernment is another person's sort of harsh no.
Yeah.
So I think it's one of those things that you do have to just let sort of be a little bit emergent and actually have the opportunities and the money bumping up against each other enough times and it will find a natural equilibrium. So I don't think, I always use the extreme, if you had a provable cure for cancer, you will have no trouble raising money at all.
Yeah, absolutely.
But nothing's that black and white. So I think you do need to have that to and fro. And again, that's where I think we need more opportunities bumping into each other to reach that equilibrium, because the more you have, the more it will sort of average out to something sensible, I think.
Yeah. Brilliant. Rightio, I'm conscious of time. I'm going to jump into some quick fire questions. But before I do that, I wanted to ask you just one quick question. If you had to look back at your journey, everything you've achieved so far, encapsulate your journey in a single lesson or a message, what would that be?
So I've been asked this before, actually, at student events when I talk to them. And the advice I always give, or the message I always give, is focus on mastery in the present. So just try and be good at whatever the thing that's in front of you is now. Yeah. Because the reality is that the big life-changing things that you think will happen almost certainly won't. And the ones that you will never expect in a million years will be the ones that have big differences to you. So again,
the one step at a time.
One step at a time, focus on the present and put in the best effort you can.
I love that. Right, beautiful. Some quick fire questions as we round off the podcast. What's one book or a book that you've given, like you read or recommended the most?
One that's actually compulsory reading for my children, and I think it's the best book in the world, is The Hitchhiker's Guide to the Galaxy.
Oh yes.
Yep.
Brilliant.
I just love the counterpoint of the big philosophical questions against the absurdity of day-to-day life.
Yeah.
So beautifully distilled in that book.
It's one of the best.
Yeah.
One of the best. What's one lesson that's taken you the longest to learn?
So I think, again, I've made some notes, but I think one that's taken me a long time to learn, coming from a very technical background, is actually that in any complex system, the most complicated and impactful bit is nearly always the people. So, coming from a very strong science background, it does take a while to hammer that into your head. But as I've got older, absolutely.
We work in change, Justin. So that is the only to be honest. Every time we go into a company, the tech does what the tech needs to do. It's the people and the way in which they can make sense of it, adapt it, get trained in it, be communicated to. Like that is the people, and it's often referred to as the soft and fluffy stuff, which is the people part. But it's not. It's the hardest part is dealing with the human beings. So
it's often what I call the wetware.
Yeah, absolutely. So what's some of the best advice that you've ever received?
So I've got two actually that I'll put out because I had to remember the quotes that I got. So one was actually back when I was a patent attorney in training, and one of the crusty old partners got up and said, we're here drafting patent specifications and you've all been told that there's no one right way to do something. We agree with that, but there's definitely a whole lot of wrong ways to do something. And a big part of success is learning to avoid them. So I thought that's a classic one.
Quite good.
And the other one I really like actually is one that came from my daughter, and she called it the Taylor Swift philosophy, which is the idea that doing something simple really, really well is often a whole lot better than trying to do something very complicated in a somewhat half-assed way.
Yeah, both amazing lessons. I think for the first one, is a real leadership. Like, if one lesson that's taken me the longest to learn is probably to your first point, is there's no one way of doing something right.
Yeah.
Which means as a leader, when I sort of say, this is the outcome I'm looking for, or go off and do this, and people don't do it in the way in which I think it should be done, it's kind of like, oh, hang on, what are you doing? Where as a leader, it's about setting those boundaries, isn't it, really?
Absolutely.
And then to your daughter's point, I mean, from what I've learned in the startup space or business space, is niching down is actually one of the most important things to do.
Absolutely.
So yes,
remove complexity.
I'm big on those two. How has failure? We've talked about failure a bit today, but how has failure or apparent failure set you up for later success? Like, do you have a favorite failure?
Well, I think it's the one that we talked about earlier, that, some people would view, the Karina handover. Why did you give up your baby? Did you see that as a failing? And to me, it absolutely wasn't. It was the best thing we ever did for the company. So I think it's learning to, I won't say stick to your lane, but this idea that, you've got a real strength. So why not just hammer away using that as much as you can? And it's not a failure to not sort of stretch yourself into areas that, are at least not your real core.
Yeah.
So that's...
Yeah, and you got to find what your unique ability is, don't you? Yeah. And what makes you sing.
Yeah.
So
absolutely.
What's one skill or talent you had or that you wish you had but you don't?
So this is one which is odd being on a podcast, but one thing I'm utterly shocking at is small talk at networking events and whatnot. It's my utter weakness, and because I watch my wife, who that is her utter superpower. Yeah. Talk to anyone about anything and chat on and their best friends in 15 minutes, and I just look at it and go,
how do you do
I
that?
just do not know how she does.
Why is that? Did your mind go into the technical?
I don't know what it is. It's just I think it's because I'm usually so busy thinking about a whole bunch of complicated things, and that idea of turning it all off and just going to the purely social joy for its own. It's something I'm just not good at.
It is tough. I think small talk's a tough thing to navigate through. Yeah. There's a quote that I love. It's by Eleanor Roosevelt, where she says, small minds discuss people, average minds discuss events, and great minds discuss ideas.
Yeah.
And sometimes when you go to those networking events and you go, oh, we have to talk about this small stuff again, when you want to be talking about the ideas and how we can change the world. So maybe you and I will get along at those networking events quite well. If you could swap lives with anyone for one day, who would it be?
Look, that was a really tough one when you gave me the list, but I've decided, given the crazy busy year I've had this year, I'm actually picking a cat.
Yeah, well, you can lick yourself all day.
It's the laziest creature I've ever seen. Sometimes I just look at her and going, now who's running the show here? Yeah, we're just your staff.
Yeah.
So so I'm picking.
Was it that?
But not for long. It's just a day.
Was it The Simpsons or something that said who actually runs the world when you've got humans running after dogs and cats picking up their shit? Yeah,
absolutely.
Yeah.
Yeah, no.
It's
every
funny.
now and then it's you go, actually, what's going on here?
Yeah, brilliant. If you could have a gigantic billboard anywhere in the world with anything written on it, what would it say and why?
Well, given my favourite book, there's only 2 words, and that has to be "Don't panic."
Yeah, don't panic.
So, but again, all joking aside, I actually think it is very good advice. I think some sort of we tend to have, particularly at the moment, a very panicky reaction to a lot of things. I think social media and electronic communication hasn't actually helped a lot. So I think a little bit of slowness and deliberation coming back into the way sort of people handle themselves would probably be actually very good for everyone.
Absolutely. Until now, I've never connected Stoicism and Hitchhiker's Guide to the Galaxy as you talk about that, because it is very much about that, controlling one's emotion. I think I was saying this to someone yesterday, happiness is a fleeting emotion, and it's essentially reality not meeting expectation, which is what panicking is.
Yeah.
Reality is not about to meet your expectation. I love it. If you were to start a podcast, what would it be about? This would be an easy one for you.
Oh yeah, so for me, it'd have to be something sciencey. But I love sort of, and again, I watch late night TV with some of those shows on, like Nine Rush, where it's sort of unexplained things like it's the Greek antikythera mechanisms, that sort of stuff that's out of place, unexplained, that sort of thing. So that's what I'd have to do as my sort of guilty pleasure.
Yeah, the mysteries of the world.
Given my small talk thing, I reckon I'd make a shocking podcast.
If you could be famous for one thing, what would it be and why?
Yeah, so this was actually a really tough one, and for me, my idea of fame is probably a lot smaller than what a lot of people would expect. So, I looked at sort of a motivation for doing all the stuff that I do, and for me, it's actually a family thing. So that's, I looked right down to the underlying driver. And for me, it's sort of obviously my own family on a very small horizon, but, even for others, ultimately you just want people to, have sort of relaxed, relatively comfortable, happy lives. So it's that sort of, which I know, it should be cure for cancer, all that sort of stuff, but it's not really underneath it all.
Yeah. Being what I'm hearing is you want to be, success to you is value in your community, almost value in your family and community.
It's a really, really hard thing to try and articulate. Like I said, I'd much rather explain molecular biology.
Yeah. If you could time travel to any event in history, where would it be?
Yeah, this was a shocker as well. And it's a weird one, but something that's always fascinated me is this concept of the beginning.
Yeah.
So, whether it's the Big Bang, it's a sort of biblical Genesis event, whether it's the simulation being turned on, whatever it is. But I think that would give real insight as to the point of it all.
You've just opened Pandora's box talking about the simulation theory on this podcast. I really like that idea about the whole simulation thing. I don't buy. It's not that I don't buy into it. I don't disregard it.
Yeah,
it's interesting.
Well, if you really geek out on it, there's some maths that makes it at least plausible.
Correct. Yeah, down to a pixel. Like the atom is the pixel. It's kind of like all the different things that can.
Well, it's the idea of the Planck length being the pixel.
Yeah, that's right. Yeah,
we could do a whole other podcast.
Yeah, we could. That's a interesting. If you became invisible, what's the first thing that you would do?
Well, being the system sort of person, the first thing I'd have to do is work out the rules. And can an invisible person see themselves? Because I'd have to look at my feet.
You've gone right to that level. Yeah. That's true. You'd look at whether you can see it. I never thought about that. Could you actually see yourself if you're invisible?
Well, I don't know. So it's the rules. Because you'd have to know. Because if you can't see your hands and feet, then you'd be worried about what you're actually then going to do.
If you could see it, then everyone else can see it.
Well,
so I'm assuming you can't see yourself.
What is the nature of the invisibility?
Oh, here we go.
Is it in external heads? Or is it
this is what we can start a podcast about, I think. If you had any superhero power, which one would it be?
Oh, look, I'm going to be flippant on this one. We're doing some renovations around our house at the moment, and I have some high gutters and eaves, which, God, I hate getting on the ladder because I've reached that age where I'll become a cliche of falling off one.
Yeah.
So super stretch for sure. So I can reach up to the gutters and paint them.
Brilliant. And last one, my favourite question of the whole podcast, what's your best dad joke?
Okay, so this has been cringe tested amongst my daughters, particularly my youngest, because she allegedly is the strongest cringe meter. So I've tried a few, but this one seemed to be the best one, and it is, how can you tell when a joke has turned into a dad joke?
How can you tell when a joke has turned into a dad joke? I don't know.
when it becomes apparent.
That's brilliant. It's so bad, it's good. I love it. Thank you very much for your time today, Justin. It's been a wonderful conversation. I guess I'm going to speak on behalf of everyone. Thank you for all the amazing work that you're doing in this industry, in the biotech industry. You are having impact on human beings and their lives and their longevity, and I think it's something you and your teams should be very, very proud of. I appreciate it, the conversation coming in. I've learned so much off you in our couple of conversations that we've had. Keep doing the amazing things that you are doing at AusHealth as well. I'm keen to watch that story grow and see some of these. Especially the Platypus one. I'll be called up for the human trial. So keep doing what you're doing, and really excited to see it grow.
Oh, thanks for having me, Daniel. It's a great opportunity.
Not a problem. If anyone wants to, where can they get in contact with you or learn more about what you guys are doing?
Yeah, look, just reach out to me at AusHealth. So you can come through our website. We've got a inquiries box, or you can email me directly at jcoombs@aushealth.com.au.
Beautiful. That's it from us. Thank you, everyone. We'll catch you next time.
Thank you.
Thanks for listening to the podcast all. You can check out the show notes if there was anything of interest to you, and find out more about us at SynergyIQ.com.au. I am going to ask, though, if you did like the podcast, it would absolutely mean the world to me if you could subscribe, rate, and review. And if you didn't like it, that's all right too. There's no need to do anything. Take care, guys. All the best.